section 1.5. And the title of the section is Rectangular Coordinates. But before we take a look at rectangular coordinates, we are going to solve my little warm-up problem over here that I just gave you. I gave you this at the very beginning of the class. Okay, so what we have here is a right triangle. How do we know this is a right triangle? I haven't told you that. So how do we know that?
Because it has a 90-degree angle and
How do you know it has a 90-degree angle?
because you marked it. But
How?
also the type of triangle,
How? How did I mark it?
the square.
Right over there. Very good. Who said that? Who's been speaking here?
Talia.
Talia, very good. Very, very good. That little square over there tells you it's a right triangle. If you know it's a right triangle, this tells you a lot of things. It tells you that this is a 90-degree angle. In a 90-degree triangle, a right triangle, this is called the leg. This is called a leg, and the side opposite the 90-degree angle is called the hypotenuse. And there is a very, very famous theorem that you've all heard about from a guy by the name of Pythagoras. Pythagoras was a Greek mathematician who did something really special about, a long time ago, over 2,000 years ago. He created a school in Alexandria, Egypt at the time. And the purpose of the school was to teach people mathematics. And parents used to send their sons, I'm sorry to tell you this, but not their daughters, but they sent their sons to the school to learn mathematics. And Pythagoras used to charge them, but he also used to say, if you found anything new, I get credit for it. So one of the things that he thinks he got credit for was something called the Pythagorean theorem. And the Pythagorean theorem tells us that the leg of the right triangle squared plus the other leg of the right triangle squared is equal to the hypotenuse squared, abbreviated HYP. And this is one of the most famous theorems in mathematics because it tells you that if you know the two legs of the right triangle, you could find the length of the hypotenuse by simply substituting in this formula. So let's do that. 5 squared plus 12 squared is equal to x squared. 5 squared plus 12 squared is equal to x squared. 25 plus 144 is equal to x squared. 169 is equal to x squared. Again, I'm going to move that around because to me, an equation is not an equation unless the variable is on the left. And then x is equal to 13 because 13 times 13 is equal to 169. So what the Pythagorean theorem is going to do for us is it's going to facilitate our ability to find the third side of a right triangle. But first, let's take a look at rectangular coordinates. What does this mean? Rectangular coordinates. And I have a little device here that I'm going to use. This is the only time I'm ever going to use graph paper. because I like to play with this. I bought this and I intend to get maximum use out of it. There's my graph paper. Pretty cool, huh? Okay. This is so I'm now going to show you what rectangular coordinates are. Rectangular coordinates come from this situation. This is called the Cartesian plane. And it's named after a French mathematician named Descartes. Does anybody speak French here? Or is from Haiti or a French-speaking nation by any chance? Okay, so there's nobody out there who will tell me that I really pronounced that name very, very well. His name was Descartes, and they named the Cartesian plane after him. And this is what they came up with, what he came up with. He said, let's take the plane and let's draw two straight lines. You don't need graph paper because you're going to be sketching it. It's okay in the future. Here's the X, we're calling this the X-axis. We're calling the vertical line the Y-axis. All along the line, which is the X-axis, Y is equal to 0. Because Y is equal to 0, because then as you go up, Y will be equal to 1, Y will be equal to 2, Y will be equal to 3, 4, 5, and so on. And then going in the negative direction, it'll be equal to -1, -2, and so on. Right in the middle, X equals 0 and Y equals 0. Right in the middle, that's called the origin. Along the X-axis, X is equal to 1, 2, 3, 4, 5, 6, 7, and so on. And then in the negative direction, -1, -2. We've actually been using just the X-axis when we graph the inequalities. But there's two axes, the X-axis and the Y-axis. And you can identify points. For example, the point 1, 1. Where is the point 1, 1? It's the point where X equals 1 and Y equals 1. So when we talk about a situation like this, this is called an ordered pair. An ordered pair. The order doesn't change. It can't be YX. It's got to be XY. And that's called an ordered pair. And let's graph that point. So that point will be where X is equal to 1, Y is equal to 1. Here it is right over here. This is the point where X is 1 and Y is 1. And let's take the point 4, 5. Again, X is equal to 4, Y is equal to 5. And let's graph what that looks like. That's out here. And then up there is the point 4, 5. And you can graph any point can be graphed on the Cartesian plane. Now, I have a question for you. I'm going to draw a line between these 2 points as straight as I possibly can. Not bad without a ruler, right? And my question, let's call this line the line AB. My question to the class is, how long is that line? Or better still, how would you go about finding out how long that line is? How would you go about doing that?
Would you turn that line into the hypotenuse and make a right triangle?
How'd you know that?
I just guessed.
Really?
Yeah,
You should be a mathematics major.
thank you.
you create a right triangle out of it by dropping the perpendicular, by letting this line intersect that line. If you want to, you could even call this point C, you know, and then it looks exactly like the one above it, you know, that we were talking about earlier. Now, in order to use the Pythagorean theorem to find out how long this line is, let's call this D, the distance. The distance between point A and point B, we need to know how long this line is and how long that line is. Now, it's very easy when you're using a beautiful graph like this, because all you have to do is count the boxes, right? One box. To get from this point to that point, you have 1, 2, 3, 4 boxes. So you know that the length of this line is 4. To get from this point to that point is 1, 2, 3 boxes. But let's put that on ice for a moment. I want to know what point this is right here. Somebody besides Talia, though.
4, 1.
Tell us how you got that.
Huh?
Who's speaking now?
Sundas.
Very good, Sundas. Tell us how you got that.
Because I went to the x-axis and it's on the 4. Then I went up, which is 1 unit up to the 1.
Good. Excellent. 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 You went from here, which is 1, to there, which is 4, and you know, and how far up have we gone? We've only gone 1. So, and you can see why this line is equal to 4, because 5 minus 1 is equal to 4. In other words, if we call this x2 and this y2, this point, point A, is x2, y2, and this point down here is x1, y1, this line can be found by subtracting y2 minus y1. Oh, because, wait a minute, this is equal to x2, y1. Okay, so I forgot to say that this is the point where x is equal to 2 and y is equal to 1. So this line is equal to y2 minus y1. And this line here is equal to x2 minus x1. That's how you find out how long this line is. Or you could just count boxes as we did. So this is equal to 3. And now the distance is equal to, well, d squared, which is the Pythagorean theorem, is equal to 5 minus 1 squared plus, I'm actually doing y squared plus x squared. So let's keep it as x squared plus y squared, okay? So 4 minus 1 plus 5 minus 1, right? And d will be equal to, therefore, the square root of 4 minus 1 squared plus 5 minus 1 squared. Or, as we determined already, this will be 3 squared plus 4 squared. And this is very easy to compute because d will be equal to the square root of 9 plus 16, which is equal to the square root of 25, which is equal to 5. The distance between point A and point B is 5. And what we just used here to figure this out is a very, very famous formula called the distance formula. The distance formula tells us, putting it over here, The distance formula tells us that if you want to find out how long a line is, the distance between 2 points on a line, you would subtract the x's and square it, subtract the y's and square it, and then take the square root. This is called the distance formula. Sometimes it doesn't come out to such a beautiful triangle like the one I drew, where everything works out like, we were told to drop the perpendicular and connect the two. That was beautiful. But what happens if if the points are anywhere and it doesn't come out to such a beautiful right triangle as that? Well, you could find the distance between 2 points anywhere by just simply following this formula. Basically, all this x2, y1, and all that stuff, it's basically saying subtract the values of x, subtract the values of y, take, square it, take the square root of that, and that will tell you how long the line is equal to. For example, if I give you the point, given the point, well, it doesn't really matter what I choose, does it? Okay, let me just make something up. 2, 1, and let's see. Here are 2 points. So in other words, pretend that I've just graphed these 2 points. And we want to find out how long the line is that connects these 2 points. Now, you could draw it if you wanted to. You could say, oh yeah, I'd like to see what this looks like. So you could say, well, this is 2, 1. That's about over there. 8, 9 is like over there. And you could connect them. This is 2, 1. This is 8, 9. Not necessary, really, because what's necessary is that you're going to use the formula that d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. D is equal to the square root. You're going to subtract the x's. You're going to subtract the y's. Let's do that. So 8 minus 2, the second value of x, minus, well, we could do this. This might help. x1, y1, x2, y2. x2 minus x1 is 8 minus 2. And then y2 minus y1, 9 minus 1. And figure that out. I'll give you a few moments to figure that out. So let me move on here. So 8 minus 2 is 6 squared plus 9 minus 1 squared, 8 squared. D is equal to the square root of 36 plus 64, which is the square root of 100, which is equal to 10. So the answer is that D is equal to 10. This is the answer to the question. That's how you used the distance formula. The distance formula, so we're back up to the top. The distance formula, which again is equal to, and there's another very, very important formula, which helps us to find the midpoint of a line. And that's called the midpoint formula. And what does this mean? This means that, when you draw a line, like let's take the same line. Nah, that's not gonna work too well. Let's take this point. Let's take the point -3, 8 and -5, 12. Okay, so -3, 8 would be like over here, a little higher probably, but I'm running out of room. And well, this is a really terrible diagram. That's the problem. The problem is not that. The problem is that I don't have enough room to create what I'm trying to create here. So -3, 8 would be, let's say, up here. -5, 12 would be over here. Okay, and the question is, what is the midpoint of this line? It's going to be somewhere in the middle. And we want to be able to figure that out. And here's the formula. The formula states that the x coordinate of the midpoint would be equal to adding up the two values of x and dividing by 2. The midpoint is like finding the average. You're finding the average between two values of x. The y coordinate of the midpoint will be y1 plus y2 over 2. Again, you're finding the average of the two values of y, and you're finding the average of the two values of x. How do you find an average? If I gave you a test, and then I gave you, and you got an 80, and then I gave you another test, and you got a 90, what would your average be? It would be equal to 80 plus 90 divided by 2. Your average would be 85. Finding the average between two grades on two tests is very similar to finding the midpoint, because you're adding up the two values and you're dividing by 2. So in this situation, if we call this x1, y1, and this x2, y2, the y coordinate of the midpoint would be equal to -3, -3 plus -5 divided by 2. The y coordinate of the midpoint would be 8 plus 12. I added the x's right here. I added the y's right here, and then we divide by 2. And this comes out to equal to -8 divided by 2 is -4. So the x coordinate of the midpoint is -4. The y coordinate of the midpoint would be 20 divided by 2 is 10. So the y coordinate of the midpoint is 10. And where would that look? What would that look like? Well, this is the -5. This is the -8, and the -4 would be right in the middle. So that makes sense. This is -4, 10. Right in between. Right in between the -5, 12 and the -3, 8 is the midpoint of that. So that's the midpoint formula right here. Those are the two very important formulas that you need to know how to use and how to find values. The distance formula and the midpoint formula.
Professor, this is Rose. I have a question.
Good.
Do we have to put the midpoint answers in like an order pair, or leave them like that?
Good question. Excellent question. Even better. Thank you. Beautiful, beautiful, Beautiful question. Beautiful question. The question was, can we just leave it as x, x sub m equals -4, y sub m equals 10? The answer is, well, you could. I'm not going to go crazy, but making it into an ordered pair is even better because now, it's actually an ordered pair. Everything looks better as an ordered pair. So you now know the distance formula. You now know the midpoint formula, hopefully. And here is the problem that will be on the test. Because I'm sure you'd be interested in that question. This is not, when I say this question will be on the test, I don't mean this exact question, obviously, right? I mean a question similar to it. So this is what the question will look like from beginning to end. So the question will say, find 1, the midpoint 2, the distance between the 2 points. So once again, I'm not only teaching the topic, but I'm also telling you the type of question that will actually be on the test. And I left out something here that I did purposely. So it should say, given, because I don't want you to start doing the problem before I finish talking. Given 2 points, -2, -4, and -4, 8. Given these 2 points, find the midpoint of the line that connects these 2 points and also find the distance between the 2 points. And I'll leave that to you to do right now. Okay, I think I'm going to begin. So let me tip this slightly over there. And I think, well, let's do the problem the way it's intended to be. So this is x1, y1. The first value of x, the second value, the first value of y, the second value of x, the second value of y. And the midpoint, the x coordinate of the midpoint will be equal to x1 plus x2 over 2. So let's do that first. And the x coordinate of the midpoint will be -2 plus -4 over 2. And now what I do is I go back and check -2 plus -4 divided by 2. Okay, that's good. And we get -6 divided by 2 equals -3. But I think that I'm just going to say that the midpoint, well, let's put it this way. The coordinates of the midpoint of the given line will be the point where x is equal to -3 and y is equal to 2. That's the first part of the problem. And that's kind of the way it'll look. I'll be giving you 2 points. I will say, find the midpoint, or I should say, really find the coordinates of the midpoint. And question 2, find the distance between the 2 points. So far, are there any questions about just finding the midpoint? Don't be shy if there's something you do not understand. Even if it's, how did you get from -2 and -4 to -6? Any question, any question. All right, well, nobody's saying anything, so I'm moving on to the second part of the question, which is to find the distance. So the distance formula is the formula x2 minus x1 squared plus y2 minus y1 squared. Okay, so notice the difference between the midpoint formula and the distance formula. This is x1 plus x2 divided by 2, right? And this is x2 minus x1 squared, just so you understand that. This is adding the y's. Here, you're subtracting the y's. So a lot of students make that mistake. So the distance formula is, and I'm kind of creating a skeletal outline of what this looks like. That's what it looks like, basically. That's this is, for many people, this is the first step. Now, let's subtract the x's. -4 minus -4 minus -2 and 8 minus -4. So let me make sure I have that right. -4, -2, 8 minus -4. Okay. Everybody okay with that? Draw a line. D equals the square root. Now you have to be careful. Now you have to be really, really careful. Because, and let me rewrite this. I'm going to rewrite this part of the problem because now a lot of modification is going to go on. Okay, so D is equal to, now let's do this here. When you subtract, when you're doing the operation of subtraction, you change the sign of the second number and you change the operation to addition. That's an algebra concept that you should know, but if you don't, I understand. -2 squared plus, again, change the sign of the second number, change the operation to addition. This is 12 squared. 8 plus 4 is 12. Equals the square root of 4 plus 144. D equals the square root of 148. And that's a good enough answer. I do not want you, really, I do not want you to take your calculators and find the square root of 148. Just right now, I'm just checking my work. -4, +2 is -2, squared is 4, 8 plus +4 squared, 12 squared, 144, 144 and 4 is 148, and that's what the distance is between the 2 points.
Hi. Janelle's cut.
Did somebody just howl a question?